Autoreg menu. In this video, we will explore the commands related to topographical design, all grouped under the Autoreg menu. Using these commands, we can design, edit, and print any topographical diagram. The text parameters command allows users to select the printable height and font for the text parameters. Under building parameters, users can select the building parameters for their desired area through the library option, which takes the relevant data into account. The grid option enables the definition of a building grid, which significantly facilitates the drafting process. In this window, users must specify the grid's angle on the x-axis, the angle of its horizontal lines, and the distances for all grid lines, both horizontal and vertical. After defining the type of lines at the top, users input the distance values into the corresponding field and press Add, transferring the values to the list on the left. The process can be repeated for additional distances. Finally, users can add text details as needed. Points. This set of commands includes a series of special options that allow the user to define the points of the plot. Specifically, these options are: independent point defines a point either with the mouse or by typing coordinates into the command line. Distances from 2 points is useful when the distances of the point we want to define from 2 other known points are given. Import points from tachymeter is used when we have a series of measurements from a tachymeter. Import points from tachymeter file is used when we have a ready file with measurements from a tachymeter. The file can be in ASCII or TXT format. With the 3D building plot commands, the program provides the ability for 3D design and visualization of the plot. Placement enables the automatic placement of a 3D plot after first defining the points. The dialog that appears has various options for defining the points. Points from file works as described above. The program reads the points from a tachymeter file in TXT or ASCII format and automatically creates the 3D plot with these points. Definition from points prompts the command line to display Select Entities. We select all the points and press Enter. In this way, the triangles on the plot are automatically created, and consequently, the 3D mesh of the plot. Definition from triangles allows the user to design the 3D plot by sequentially defining the triangles that compose it. With the frame commands, the user can define the external outline of the 3D plot by either sequentially selecting the points that compose it, selecting a polyline that forms the outline, if it has already been created, or deriving it from the corresponding 2D plot, once it has been defined. Finally, with the Process Points option, we can add, move, delete, or change the elevation of any point on the outline. Contour lines. The program asks us to select the 3D plot we have defined, on which we want to determine the contour lines. Next, it asks for the elevation difference between the contour lines. Finally, it asks for the curvature radius, in order for the contour lines to appear smoother. Excavations. With this option, we are first asked to select the 3D plot. Then, a message appears prompting us to select the excavation outline. We select the polyline we previously designed that defines the excavation boundary. Finally, the program asks us to provide the elevation of the plot. This is where we specify the depth from which the excavation will begin. Ideal solid body. This command creates the ideal solid. The definition of the ideal solid requires the plot to have been defined as a 3D plot and for the building line to have been placed within the plot using the corresponding command from the Autoreg menu. Street. With this command, we can easily design the streets adjacent to the plot, which also assist in the creation of the ideal solid. Plot. Building plot definition is performed using this command, which allows the plot to be defined by specifying its vertices. The dialog that opens with this command provides various options for defining the vertices of the plot. This can be done either by using points from a file, where the program reads the points from a tachymeter file, similar to the 3D plot process, and automatically defines the boundary of the plot, or by sequentially selecting the points that compose the boundary. It is also possible to select the points collectively using a selection window. Additionally, the plot boundary can be defined using a polyline or from the 3D plot, provided that it has been defined beforehand. Once the plot is defined, we can specify whether the vertices will be displayed as letters, digits, or simple points. We can choose whether the length of the sides will be displayed or not. Additionally, we can determine which sides of the plot represent external sides, frontier sides, or neighbor. By selecting one of these options and clicking on a side of the plot, it is classified accordingly, and the line style is updated simultaneously. Finally, using the Process Points options, we can modify the plot boundary as needed. This option also displays the detailed area calculation of the plot on the screen in 3 ways. The Heron's method with triangles prompts the program to ask for the location where we want the calculation text to be placed. Then, it prompts us to sequentially select the triangles that make up the plot. Rectangular coordinates. In this case, we select plot area measurement and then orthogonal coordinates. The program only asks for the insertion point, which is the point where the table will be placed. Building plot area. By selecting the building plot area, the area of the plot in square meters and its perimeter in meters are displayed at the bottom of the screen. Adjacent building plots. With this command, we can edit a neighboring plot if we have defined the points that outline it relative to our main plot. The commands described earlier for our plot also apply to neighboring plots. Additional options. The building line option automatically draws the building line of the plot using the information contained in the plot. The north symbol option allows us to define the position of the north symbol in our drawing. The diagonal command allows us to easily draw a diagonal of the plot or, more generally, any distance. The street naming command allows us to easily label roads and other text on the topographical drawing, parallel to the plot's sides, roads, and other lines. The altitude command is used to place elevation frames for each point of the plot. There are two sub-options, from a building plot point and from a point. Building outline. With this command, we design the outline of the building as desired in relation to the building line. Modify building. With this command, we can easily modify the outline of the building while observing the coverage area in real time. Characters size. This command is used to define the size of the characters in the topographical drawing. Orthophoto maps. With the orthophoto map import, the user can insert an orthophoto map file. The file can be in BMP, PNG, JPEG, or TIFF format. The orthophoto map is automatically placed at the correct coordinates with its initial resolution, but the user can modify all these parameters. Web image, Google Earth. This command is used to locate the plot via Google Earth or another website and to import a map image of the plot or part of the map of the area. Building parameters text. With this command, the table of building parameters for the topographic diagram is designed in the desired position within the drawing. It is noted that the building parameters text appears in the form of mtext within our drawing, which can be edited using the Modify Text command.